Sovrium's S1 completion was a major milestone. S1 was not just about showing that the network was running, it was a 7-day public testnet stability proof. During this period, the Sovrium public testnet was continuously monitored. The service remained active, the RPC stayed responsive, ports and listeners stayed in the expected state, and most importantly, the proof was completed without any restart, build, deploy, or push during the observation window. That means Sovrium now has a clean and trusted baseline. This baseline is very important. If any future patch, RPC change, validator update, or public opening step creates an issue, we can compare it against the S1 baseline and clearly understand what changed. In simple words, S1 gave Sovrium a working testnet base, but after S1, we did not directly open everything to the public. A stable network is one thing. A network that is safe, developer usable, node runner ready, validator prepared, and community ready is another thing. That is why Sovrium moved into the Post-S1 audit phase. The Post-S1 audit from A1 to A8 reviewed Sovrium from multiple important angles. A1 locked the audit scope and evidence boundaries. This made the audit structured, controlled, and evidence-based. A2 reviewed the core chain security, including chain state, block handling, consensus assumptions, runtime behavior, and core safety boundaries. This helps create a stronger foundation for developers and validators. A3 reviewed RPC and API security. This is one of the most important areas because developers, wallets, explorers, faucets, tools, and community applications will mostly interact with Sovrium through RPC and APIs. A4 reviewed the website, explorer, and front-end. This helped confirm that public-facing pages are not showing confusing data, fake claims, or unsafe messaging. A5 reviewed the SFA-S20 lifecycle, including minting, transfer, burn, supply rules, receipt proofs, and explorer visibility. This will help future developers build safer token and asset workflows on Sovrium. A6 reviewed node runner and validator readiness. This includes node setup, ports, configuration, logs, monitoring, and onboarding risks. This is directly useful for people who will run Sovrium nodes or prepare for validator participation. A7 reviewed the higher security posture, including front-end exposure, secret file risks, misconfiguration risks, and public-facing attack surfaces. A8 classified the final findings. The good news is critical count was 0. That means no critical blocker was found. But 3 high-risk blockers were identified: source control path, secret risk files, and public port exposure. This means Sovrium is close to open testing, but before full public opening, these high-risk items must be closed in a controlled way. After that, Sovrium completed the A9P10 phase. A 9P10 was not a technical patch. It was a public communication safety gate. Its purpose was to make sure Sovrium is not accidentally presented as a mainnet launch, a production launch, an investment opportunity, a token sale, an airdrop campaign, or a guaranteed performance claim. This is very important because Sovrium is currently in public testnet readiness progression. Clear and honest communication protects the project, the community, and the long-term credibility of Sovrium. A 9P10 created a safe communication framework. The result is simple. Sovrium can communicate professionally, without hype, without compliance confusion, and without false mainnet or production claims. Now, the next major gate is a 9P11, public RPC exposure hardening. A 9P11 is the first real technical opening blocker. Public RPC is necessary for developers and the community. But if public RPC is open without proper hardening, it can create serious risks: spam requests, RPC overload, unsafe method access, explorer or faucet impact, resource exhaustion, and validator private infrastructure risk. The goal of A9P11 is to make public RPC developer-friendly but abuse-resistant. This means Sovrium will define which RPC stays public, which private or admin RPC stays local or restricted, which unsafe methods must be blocked, where rate limiting should be added, how Nginx or firewall boundaries should protect the endpoint, how COR's policy should be controlled, and what correct public RPC endpoint should be published in the docs. For developers, this means stable access to RPC, Explorer, Faucet docs, SDK testing, contract testing, and application integration. For node runners, this means safe port policy, setup guidance, monitoring flow, and clearer runbooks. For validators, this means safer onboarding, cleaner secret boundaries, and better separation between public access and private control paths. For the community, this means stable Explorer access, Faucet access, public testing tools, and clear updates. The fastest safe opening roadmap is clear. First, a 9P11. A will lock the RPC exposure scope. Then A 9P11B will inventory the current ports and RPC methods. A 9P11C will create the hardening patch plan. A 9P11D will require explicit operator approval before any production change. A 9P11E will apply the controlled production patch. A 9P11F will run post-patch smoke verification. And a 9P11G will run a 24-hour stability monitor to confirm the new hardened baseline remains stable. After a 9P11, the next wave will include secret risk cleanup, source control and path cleanup, node runner package, validator onboarding package, and finally the public testnet opening gate. At the end of this process, Sovrium will not just be a testnet that is running, it will be a controlled, safer, developer-usable, node runner-ready, validator-prepared, and community-accessible public testnet ecosystem. This is not a mainnet claim. This is not a production launch claim. This is a serious public testnet readiness progression. S1 proved that Sovrium can remain stable. A 1 to A8 discovered and classified the risks. A 9P10 made the communication safe. A 9P11 will harden the first real public opening blocker. The goal is simple: move Sovrium from a working testnet base to a full open, workable public testing stage in a safe and controlled order.